All the class 8 students of St. Michaels Academy, welcome to another physical science class. Today I am continuing magnetism part 2. So let's start the revision. So I am starting with magnetic poles. Either of the two ends of a magnet at which the field of the magnet is almost intense are called magnetic poles. Each pole is designated by the approximate geographic direction in which it points, either north or south. Like magnetic poles repel, opposite magnetic poles attract. See the diagram? Opposite poles are attracting each other, that means north and south. Both the poles are there, they are attracting each other. By arrow diagram I have shown. And in the second one, similar poles, that means two south poles, are repelling each other. So arrow direction are in opposite sides. So there are two types of magnetic poles called the north magnetic pole and south magnetic pole. North magnetic poles are those that are attracted towards the Earth's geographic north pole. Like poles repel and unlike poles attract. If a bar magnet be dipped in iron fillings and then when lifted, it is found that lumps of fillings cling to it at or near the ends only, and very few or no fillings cling to the middle portion of the magnet. So powers of attraction of the magnet are maximum at its ends. The regions at the ends of a magnet where its attractive powers are most pronounced are called poles of the magnet. Pronounced means mostly strong. The poles are not just at the ends of the magnet, but situated at points close to the ends. There are two poles of a magnet. When a magnet is suspended freely, it sets itself along north-south direction when at rest. A particular end of the magnet always points towards north and the other end towards south because of its directive property. In equilibrium position, the pole which points towards north is called north pole and the other is called south pole. Equilibrium position means in a balanced position. That means when one magnet or bar magnet is showing its directive property. Magnetic axis and magnetic length. Magnetic axis is defined as the line which joins the two poles of a magnet. It is also the center line of bar magnet that crosses both the poles with the applied torque. It has irregular path. Please see the diagram. Here magnetic axis has been drawn, that dotted line, which is in between magnetic poles. So the imaginary straight line passing through the poles of a magnet is called its magnetic axis. Now, what is magnetic length? The distance between the two magnetic poles is called the magnetic length. A bar magnet consists of two equal and opposite magnetic poles separated by a small distance. See the diagram. Magnetic length. Magnetic axis is there and magnetic length. Just distance between the two poles given over here. That means magnetic length, the distance between the poles of a magnet along the magnetic axis, is called magnetic length of the magnet. It is also called effective length or equivalent length of a magnet. For a good magnet, magnetic length is about 85% of its geometric length. Now we have seen what is actually geometric length. It is in the diagram only. So if this is 85% of geometric length, that means this magnet is a good magnet. Region, magnetic meridian and magnetic field. First, I am discussing neutral region. Two regions having no electric field are on the ends of the device and are termed quasi-neutral regions. The depletion region has an electric field. Actually, neutral region of magnetic bar is generally called quasi-neutral regions. So what is the actual definition? There is no attracting power near the middle portion of magnet. This region of the magnet is called neutral region of magnet. Now, magnetic meridian. The magnetic meridian is an equivalent imaginary line connecting the magnetic south and north poles and can be taken as the horizontal component of magnetic force lines along the surface of the earth. Therefore, a compass needle will be parallel to the magnetic meridian. So, at any place, the imaginary vertical plane passing through the magnetic axis of a freely suspended magnet is called the magnetic meridian of that place. Now, magnetic field. Magnetic field is a vector field that describes the magnetic influence of electric charges in relative motion and magnetized materials. A charge that is moving parallel to a current of outer charges experiences a force perpendicular to its own velocity. The region around a magnet when its magnetic force is exerted on magnetic poles placed there is called its magnetic field. Now see the diagram. Magnetic meridian you have understood like this, and the second diagram is for magnetic field. How the magnetic field extends around a bar magnet, it has been shown over here. Now methods of magnetization. Artificial methods of making magnets are called magnetization. Methods of magnetization are basically of two types, mechanical and electrical. Now, mechanical method of magnetization. There are four methods of making magnets. One, single touch method. Second one, divided touch method. Third one, double touch method. And number four, using electric current. 1, 2 and 3 are of mechanical method of magnetization, and the last one is electrical method of magnetization. Now let's start. The single touch method is one of various ways of making a magnetic material like soft iron into a magnet. In this method, one end of the magnet, say North Pole, is placed at one end, say end A of the iron piece, and then rubbed over the bar from end to other, that means say end B, then lifted and brought back to first end. A steel bar is placed on a table. See the diagram, you will understand. Then a bar magnet is taken and its north pole is touched to the left hand side of the steel bar and drawn along the bar to the end. The magnet is now lifted and placed again on end A of the bar and drawn up to next end. The whole process is repeated a number of times. It would be found that steel bar has been magnetized with end A being a north pole and end B south pole. One more thing, I have already told you previously, you have to draw this diagram with proper arrow, and you have to give the direction of the arrow also properly. Now the next method, that is divided touch method. Take another two strong permanent magnets and bring their opposite poles and touch them in the middle of the rod and gently rub the two magnets on the rod, moving away from each other towards the end. When ends are reached, lift away the magnets and bring back them again at the starting position. In your book, experiment has been given. I am also explaining your experiment. Diagram obviously I have given like your book, but in one paragraph I have actually explained the total method. Now a steel bar. Now see the diagram. Here steel, here iron rod we have taken. So a bar is kept on the table, steel bar or iron rod. Two opposite poles poles north and south of two bar magnets kept side by side and placed at the middle of the steel bar. Hope so you have understood. Now, the magnets are drawn on the bar towards its two ends. Then the magnets are lifted and again placed at the middle of the bar, and the process is repeated. After a few such repetition of the process, the steel will be magnetized. Here iron will be magnetized. The polarities developed at the ends of the steel bar or iron bar are opposite to that of the stroking poles. The bar will acquire stronger magnetization when its two ends are placed on two opposite poles of two other magnets as shown in this diagram. It may be noted that the pole under any end of the bar should be similar to the striking pole or stroking pole at the end. Now, double touch method and electrical methods. Double touch method is the simplest and also the most convenient method to make a small magnet that doesn't have a very big field of attraction. See the diagram? Now I am explaining. It is similar to divided touch method, only difference being that between the opposite poles of magnetizing magnets placed on the middle of the steel bar, a piece of wood or cork is kept and whole thing is then drawn together to one end, then without lifting drawn back to the other end. The process is repeated a number of times. The bar will be found to be magnetized with polarities developed at the ends opposite to that of the nearer stroking pole. As in the above case, stronger magnetization can be produced by placing bar on two opposite poles of two other magnets. So it is as same as divided touch method, where only difference is in between the two stroking magnet, one piece of wood has been placed. And like this, it has been drawn, no lifting occurs. Now the last method, that is electrical method. Electrical method for magnetization. A direct current flowing into a solenoid, that is a long insulated wire coiled into a cylinder. See the diagram, one solenoid has been given, produces a magnetic field that inside the coil is uniform in strength and direction. The solenoid becomes a magnet. So in electrical method, on the rod to be magnetized, insulated copper wire is wound from its one end to the other. Now, on sending direct current through the wire, the rod is found to have been magnetized. To determine the polarities developed, if looking from one end of the rod, the current in that end is found to be flowing in clockwise direction, then polarity developed in that end would be a south pole. And if it is in anti-clockwise direction, then that end would be a north pole. If rod be made of steel or some alloy, the magnet would be a permanent magnet, and if it be of soft iron, the magnet would be stronger but temporary one. That is, as long as current flows, the rod would be a magnet, and as soon as the current is stopped, the rod would lose its all magnetism. This type of magnet is called electromagnet. Now see the diagram. When you are seeing the magnet, from which direction, so it will depend that which one is north pole and which pole is south pole. Now repulsion is the surer test for magnetization. Repulsion is the sure test for magnetism because it takes place only between two like poles of a magnet, whereas attraction takes place between two unlike poles of a magnet and also between a magnet and a magnetic material. See the diagram. Clear diagram has been given. I am explaining this diagram. In front of any pole of a hanging bar magnet, let a north pole of another bar magnet be brought. It would be seen that there is repulsion between them. Again, if two different poles be brought near each other, that is north and south, there will be attraction between them. See the two diagrams, you'll understand. So like poles repel each other and unlike poles attract each other. We know that there may be attraction between a magnet and a magnetic substance like iron, and also between two unlike poles of two magnets. So from the attraction between a magnet and another rod, we are not sure whether the other rod is magnet or a magnetic substance. But as repulsion takes place between only two like poles, so if there is repulsion between a magnet and another rod, then we are sure that the other body is also a magnet. Hence, repulsion is the surer test of magnetization. Now we are going to start magnetic induction. If a magnet be brought near or in contact with a magnetic substance, the latter is found to have been magnetized temporarily. This phenomenon is known as magnetic induction. Here, the magnetic substance is said to be magnetized due to induction. Magnetism acquired by that particular substance is induced magnetism. Magnetic substance is said to be magnetized due to induction. Magnetism acquired by it is induced magnetism, and the magnet is called inducing magnet. On removing the magnet, it is found that the magnetic substance almost completely loses its induced magnetism. That is, induced magnetism is a temporary one and lasts as long as the inducing magnet is present. So, the process by which an object or material is magnetized by an external magnetic field is called magnetic induction. Induced magnetism is when a piece of unmagnetized magnetic material touches or is brought near to the pole of a permanent magnet, it becomes a magnet itself. The magnetism is induced. A north pole induces a north pole in the far end. See the first diagram. Induced magnetism has been shown. This experiment, induced magnetism is the magnetism of an object as a result of an external influence. I am describing this experiment. A simple experiment can be performed on magnetic induction. As iron nail easily gets attached to a bar magnet being attracted by it, in this way a few number of nails may remain attached one after another with the magnet. Here, the first nail is first magnetized by induction. This induced magnet affects other nails and those become temporary magnets. If we remove the bar magnet and the nails also get detached. Hope so you have understood the diagram clearly. Now, when a piece of unmagnetized magnetic material touches or is brought near to the pole of a permanent magnet, it becomes a magnet itself. The magnetism is induced. A north pole induces a north pole in the far end. That only I have told you. Okay. So see the next diagram. That is permanent magnet and magnetic material, for example, iron rod taken. But after induction, just opposite to south pole, north pole has been induced. That's why the opposite pole, that means south pole, has been induced in that particular iron rod. So poles developed in induced magnet, you can decide like this. A bar magnet and a magnetic needle are placed in same horizontal plane with their north poles facing each other, and the bar magnet is in such a distance from the needle that the magnet has no effect on the needle. Now a soft iron bar is placed between them. It would be found that the needle gets deflected due to repulsion. The needle gets deflected due to repulsion. How? That is, this iron bar has been magnetized due to induction and north pole has developed at the end. That means which is nearer to that end. And hence that needle. and hence south pole is induced in the opposite end. So we find that when a magnetic substance is magnetized due to induction, opposite polarity is developed at the end of it, which is nearest to the including or inducing pole, and similar polarity at the end furthest from the inducing pole. Now, induction precedes attraction. When a piece of magnetic material is brought near a magnet, it first becomes a magnet by induction and then it is attraction. Thus, we say that induction precedes attraction. See the diagram. A charged rod is there. Before attraction, a simple metal is there. First induction occurred. That's why this charged rod opposite pole, that is positive pole, has been formed over this metal. That's why opposite poles attract each other. So when a piece of iron is brought near one end of a magnet, the nearer end of piece acquires an opposite polarity by magnetic induction. Since unlike poles attract each other, therefore iron piece is attracted towards the end of a magnet. The piece of iron first becomes a magnet by induction and then is attracted. Thus, induction precedes attraction. So, when a magnet is brought near a magnetic substance, the magnetic substance gets magnetized due to induction, and opposite polarity to that of inducing pole is developed at the nearest end, and as a result, attraction takes place between them. So, induction precedes attraction. Thank you, students. For any doubts or queries, please email me at shudeshnavan.sma@outlook.com. Even you need to send your regular physical science, homework, worksheet, assignment, everything in the given email ID.